In this video and the next video, we're going to look at solving exponential equations. In this first video, we're going to look at equations with exponents where the variable is in the exponent, where you can get the same base, because we're going to use the concept that if a, and this is my a, has to be positive and not equal to 1, if a to the n power equals a to the m power, then that implies, and this actually goes both ways, that our exponents, n and m, are equal. We had a similar principle that if the logarithm base a of n was equal to the logarithm base a of m, then n and m were equal. And we use those to solve logarithmic equations. And here we have the exponential version of that principle. So for instance, say we have 7 to the x power is equal to 49. What we want to try to do is get the same base, the same exact number to a power. Here I have 7 and here I have 49. So if I can rewrite 49 as 7 to a power, then I can use that principle. And we know that 49 is the same thing as 7 squared. And now our two bases, here and here, are exactly the same thing. So our process was to rewrite this part as 7 to some power, which we did here. And now we can use our principle that if 7 to the x power equals 7 squared, then our two exponents are equal. So x equals 2. And we've actually been using this process, this principle, earlier when we were learning about exponential and logarithmic values. Let's try another one. Let's say that I have 2 to the x minus 7 power is equal to 32. And what I want to do here is I want to see if I can rewrite this base 2 and this 32 as some number to a power. Well, 2 is prime, so it can't be written as anything but 2. But can I write 32 as 2 to some power? Can I do that? And I see yes, I can. I can rewrite 32 as 2 to the 5th power, because if I multiply 2 times itself 5 times, it equals 32. And this one we just bring down. And now we see that we have the exact same base 2. So we were rewriting 32 as 2 to a power. Now that we have the same base, we can use our principle and we can set our two exponents equal and solve for x. And notice on these that I don't have to double check anything about the exponent. If x equals 12, I have 12 minus 7 is 5. Up here I had x equals 2. I don't have to worry about if I have a positive or a negative or zero exponent, because remember, exponential equations have a domain of all real numbers. So the exponent can be any kind of number. Let's try another one. Let's say on this one, I have 27 to the 4x plus 1 power equals 81 to the 2x power. And what I'm trying to do is to see if I can rewrite each of my bases here as some number to a power, the same number to a power. Can I rewrite 27 as some number to a power? Can I rewrite 81 as some number to a power where this number and this number are the same? Well, 27 times 27, 27 squared, is 729. So that's obviously way too big. It's not 81. So I need to think of a third number that I can write to a power equals 27 and to a power equals 81. I want you to pause the video and spend a few minutes and see if you can figure that out. And hopefully you figured out that 27 is equal to 3 cubed and 81 is 3 to the 4th power. So what we're going to do is we're going to replace the 27 with what it's equal to, 3 cubed. But we still have our exponent 4x plus 1. And then we're going to replace the 81 with what it's equal to, 3 to the 4th power. But we still have the exponent 2x. And remember, if you take an exponent of an exponent, you multiply the exponents. For instance, x squared cubed is x to the 6th power. So you multiply the two exponents. So over here we have 3, and then we're going to take this exponent times this exponent. So 3 times 4x plus 1. And on this side we still have our base 3, and we take 4 times 2x. So we have 12x plus 3 and 8x as our two exponents. So now we're to the place where we have some number a to the n power equals the same number a to the m power, and that implies that n equals m. We have the same exact base here and here, so we can set our two exponents equal to each other, and then we can solve for x. And we see that we have x equals -3/4. And that's totally fine. If I plug back in and I have a negative exponent or 0 exponent or positive exponent, it doesn't matter because our domain on exponents is all real numbers. So when we have an exponential equation, and that means an equation with the variable in the exponent, if we can get the same base and then set our two exponents equal to each other, that's going to be the easiest way of solving it. In our next video, we're going to look at what do we do if we cannot get the same